Section 6-7, Inverse Relations and Functions, Part 2. At the end of today's lesson, students are going to be able to determine if the inverse of is a relation or a function. In example 1, we are going to find the domain and the range of the given function. Then we're going to find the inverse, the domain and the range of the inverse, and is the inverse a function, okay? So the function that was given to us is 6 minus 4x. If you don't like it written like that, you could change it to something you're used to seeing. G of x equals negative 4x plus 6. And I hope you know that this is a line, and the line has negative slope since it's a negative 4. So since it's a line, the domain and the range is all real numbers. Okay. Now in part B, let's actually find the inverse. So first step, change g of x to y. It doesn't matter whether you use the first equation or the second one. Then after we change g of x to y, we switch the x and the y variable. And then we have to solve for y. So to move positive 6 to the other side, we subtract it. So we get x minus 6 equals negative 4y. And then to get rid of the negative 4, we divide by negative 4. And so for part B, we would say that the inverse, g to the negative 1 of x, is x minus 6 over negative 4. Okay, so to find in part C the domain and the range of the inverse, this is really easy. You take the domain and the range of the original function and you switch them, so the range becomes the domain and the domain becomes the range. So in this case still, the domain is all real numbers and the range is all real numbers because when you switch them, they stay the same. Now, in part D, the question is the inverse a function? So you check out your inverse, and as long as there's no plus or minus sign together, it is a function. So yes, it is a function. Let's look at our second example and do the exact same thing. So this time we have f of x equals x plus 1 quantity squared minus 3. All right, so to talk about the domain and the range in part A, we have to remember what this looks like, okay? So a long time ago, we graphed this. Since it has 2 as the exponent, it's a parabola. The plus 1 moves it to the left 1, and the minus 3 moves it down 3. So since it's a parabola, your domain is all real numbers. The range, since it was moved down 3, is greater than or equal to negative 3. All right, now let's find the inverse in part B. So we change f of x to y. And then we switch x and y. All right, to move negative 3 to the other side, you add 3. To get rid of the squared, you have to take the square root of both sides. When you take the square root, you get plus or minus the square root of x plus 3. And then to move the minus 1 to the other side, you subtract 1. And we normally write it out in front so that way we don't get confused with combining it underneath something. So the inverse, f to the negative 1 of x, equals negative 1 plus or minus the square root of x plus 3. All right. Part C says the domain and the range of the inverse. So the domain of the inverse and the range of the inverse. So remember, like I said earlier, you take them and you switch them. So the domain becomes the range. So my range is now all real numbers. And the range becomes my domain. So normally you would switch it and you would get y is greater than or equal to negative 3. But remember, domain is talking about x values, so you have to change the y to an x. So it's x is greater than or equal to negative 3. All right, in part D, it's is the inverse a function? And then remember in that last slide I said if there was a plus or a minus, that makes it not a function. So since we have this plus or minus, this is not a function. So compositions of functions, if I give you the inverse of f of x, when you find the composition, it should equal x. And vice versa, if you did f of the inverse of x, it should also equal x. So let's look at an example of the composition of inverse functions. So I give you g of x equals 4 divided by x plus 2. And then I want to do both part A and part B. So g of the inverse of g of 0, and then part B, which is the inverse of g of 0, okay? So when you go to start to rewrite this, remember you have g parentheses the inverse of g of 0. So if you were to start to plug in 0 into the inverse, do I have my inverse yet? So hopefully all of you said no, we don't have the inverse yet. So that needs to be our first step, okay? So change g of x to y. And then we need to switch x and y. And then we need to solve for y. So remember, there's an invisible 1 over the x, and we just need to cross multiply, okay? So 1 times 4 is 4, and then we have x times y plus 2. All right, to get rid of my x, I'm going to divide both sides by x. So that gives me 4 over x equals y plus 2. And then to get rid of the plus 2 at the end, we just subtract 2. So the inverse, g to the negative 1 of x equals 4 over x minus 2. Now that we found the inverse, we can go ahead and start to solve for the composition. So we have g negative 1 of 0. Okay, so remember, first thing we do is we plug 0 into the inverse first. So g to the negative 1 of 0 gives me 4 divided by 0 minus 2. So if you were to pick up your calculator and do 4 divided by 0, your calculator should say error. And the reason it says error is because it's undefined. You can't divide by 0. So since this is undefined, you have to stop there. You can't move on, and your answer is undefined. Now let's see if part B will work for us, okay? So we have the inverse of g of 0. So first step, plug 0 in for your g of x that was given to you. So that is 4 divided by 0 plus 2. 0 plus 2 is 2. And 4 divided by 2 is 2. Good, so that was farther than we got in our last problem. So now we take 2 and we plug it in for the inverse. So our inverse was 4 over 2 minus 2. So 4 divided by 2 is 2, and 2 minus 2 is 0, okay? So if you look back to the composition of inverse functions that we wrote down, I wrote f to the negative 1 of f of x equals x, okay? That should make sense. In this problem, the inverse of f of 0 should equal 0. These two things either have to be the exact same thing, or the only other answer it could be is undefined.